A new day is dawning for the seismic contractor. A day in which small crews are efficiently acquiring data at far less cost through the use of Oyo Geospace's GSR Autonomous Nodal Data Acquisition System. With the Geospace Seismic Recorder, crews can begin working as soon as the sun rises or whenever the source is ready, adding hours of profitable production while conventional crews would be troubleshooting cables and lines.
What do oil companies want? They want high-quality data, they want it acquired safely, and they want it as cheap as they can possibly get it. And those are the drivers in the industry. They've always been the drivers in the industry. The guy who wins in the seismic game is the guy who acquires his data for less cost and still puts some money in his jeans at the end of the day. We decided that if we were going to do it faster and better than the competitors, then we had to be the ones to go out and take a chance and explore new technology. And new technology today is wireless technology. We looked at the 4 technologies on the market today. All of them have good and bad attributes. But at the end of the day, the Oyo system was simple, it was smart, it was efficient, and it was built for a seismic company to endure hardship. We needed a system where the batteries would last 30 days. We needed a system where we knew we could leave the boxes out for 2 weeks at a time and not run out of memory. And of all the systems on the market, Oyo offered those features.
The GSR Geospace Seismic Recorder is designed for autonomous nodal data acquisition. The self-contained unit includes 1, 2, 3, or 4 channels of 24-bit digitization, an integrated high-sensitivity GPS receiver, built-in test signal generator, up to 4 gigabytes per channel of non-volatile solid-state data storage, and a high-speed data port. The unit is housed in a sealed case with an input connector and an extended life battery data port connector. The weight of the recorder is less than 1 kilogram. The batteries are lithium polymer and are housed in a sealed aluminum container. The system accepts standard analog sensor input and is compatible with vibratory, explosive, and impulsive energy sources. Sample intervals supported are 4, 2, 1, 0.5, and 0.25 milliseconds. The GSR system includes power management features that control power consumption and extend battery life. Power management allows batteries to remain deployed during disruptions or delays in the shooting schedule, such as in bad weather. When normal shooting operations resume, the operator doesn't need to spend valuable field time gathering, recharging, and redeploying batteries before resuming operations. Batteries will last throughout active recording and can conveniently be recharged if necessary when the GSR's seismic data is harvested.
Some of the biggest issues with wireless technology are battery management. What happens if you have weather and your spread is stuck out there for 12 or 15 days? And you're out there with a wireless system with 3,000 batteries on the ground, and now you have a battery problem. What do? Well, you lose 2 or 3 days of productivity going out and having to service your spread. So it was a huge concern with us. Looking at the Oyo system with their claim of a 30-day battery life and 740 hours of recording memory, I felt very confident that we could go into virtually any situation and feel secure that after we deployed our spread, regardless of weather conditions or other obstacles that might face us, we would not have to be in a position to go out there and service that spread. We've had absolutely no issues with batteries today. The memory's lasting, the battery's lasting, and I'm actually absolutely thrilled with the performance of the system and that it does do what Oyo claimed it would.
Currently with the lithium batteries that we have on hand with Viking, it takes 4 hours for a completely discharged battery to be charged to fully charged, which allows us to utilize that battery for for 30 consecutive days from -30 to +40 Celsius. So a 4-hour charge nets us 30 days. With the lithium polymer battery, we've had some boxes out for 20 days and we've looked at the voltage difference on the battery from the line viewer data. And with that 15 to 20 day time period, we have lost 0.2 to 0.5 of a volt in the battery. On a conventional cable system, you would have changed the battery out twice by that time. So it's remarkable, the battery life expectancy of it.
When we first got here, we laid out our GSRs, and due to rain, we were not able to shoot. We were not able to get out in the fields and pick any of the GSRs up. And they stayed out for 15 days, the original GSRs. And when we picked them up, none of the batteries had gone dead. Not a single one had gone dead. And the boxes all had a lot of storage, data storage left in them.
The battery and power management technology provided by Oyo Geospace's GSR systems is robustly engineered and has been undeniably field-proven, giving the seismic contractor the confidence that each GSR station in his spread will be fully powered and ready to perform when needed. GSRs are placed into the Data Transfer Module, DTM, to download data stored in their flash memory to the GeoRes XTC data management system. Depending upon the computing configuration, multiple GSR units can be downloaded at once into high-speed RAID memory.
Typically, reaping the data is about a minute a day. So by the time the individual's at the bottom of the rack, we have the capability to pull in 144 GSRs through our rack. So when the GSRs are loaded in the rack, when the individual loading is at the bottom of the rack, the top GSRs are already reaped. The data is pulled out of them.
Right now we have 144 racks for GSRs downloading. We can download this data around 15 minutes. Then after they are ready to send back to the field. Whenever we finish one sweep, we pick up whole line, send back to the recorder, then send back to the field and layout. It's a very easy process for us.
The GeoRes XTC data management system contains software modules that can program GSR deployment parameters and allow the system to read, import, and manipulate the data downloaded from the GSR's flash memory. The data can then be output to the field database in RAID memory and/or to hard media like tape or disk. The GSR Field Management Console, FMC, provides the operator with centralized tools to plan, control, and execute seismic survey field operations.
The Field Management Console actually manages all your GSRs, where they're laid out, which ones have been picked up, which ones still need to be picked up, your complete lines. When you're shooting, you know which lines are active, which lines are inactive, which lines you need to have active for the shooting. With the new FMC system we have, you have a new visibility of your spread that we've never had before. We take our line viewer data and read it into the FMC, and from that we know where each box is deployed. We know what his battery voltage is, what his forecast for any battery dead time, forecast for a memory dead time. We can keep track of all of our system, all of our GSRs that are laid out.
Currently with the FMC, the Field Management Console, in the recorder, it's integrated with a third-party software that we use, which is TigerNav for the source navigation. We've worked extensively with TigerNav and Oyo to integrate the two systems. So the observer interface with the FMC is actually very limited. The observer will sit in front of the FMC to make sure that the spreads are populated prior to the shooting day. But at that time, the system is taken over by the TigerNav. So when the vibes are on point, it's sending a ready message. The FMC receives the ready message, cues that shot point, and executes fire command. So as far as the observers where they used to be hands-on, it's more of a hands-off environment, allowing the observer to spend more time to look at the real-time quality control of the vibrator performance now.
The FMC has been engineered to support diverse autonomous data acquisition methods. Using SPS files, the FMC establishes planned locations of source and receiver points. From the GSR line viewer, the FMC imports data to track GSR deployment status. By importing planned GSR scripts, the FMC can predict the battery and memory state of each GSR. The FMC can manage all industry standard source controls, including vibro size, dynamite, and weight drop sources via the GSR SI hardware interfaces. The FMC allows the observer to track shots ready, shots acquired, shots rejected, and shots aborted on the active GSR spread. It is source-driven and completely portable capable, making the GSR system a practically hands-free operation.
If you're out there and your concern is that you're having technology failures, such as boxes, batteries, or your geophones, then I think you have a huge problem. But if you're out there with a technology where you've got confidence that those boxes are working, your batteries are working, and your geophones are working, now it really just comes down to the environment to create spread problems. When you don't have cables out on your spread, that reduces 90% of your environmental problems for spread downtime. And the fact is, we're seeing it today. We've checked, I think, to date, somewhere in the neighborhood of 17,000 channels out on our spread. And we've had to repair or change out 20 stations to date out of 17,000. Like, it's absolutely phenomenal. The performance of the system has exceeded all our expectations when it comes down to dead traces online. And again, given us such a feeling of confidence on this crew that we are now strategically QCing our spread as it makes sense. And the proof is in the quality of the data, which we're transcribing and processing today.
What happens is the observer is in the recorder, the system's fired up at 6:30, quarter to 7. The vibes are in production by 7 o'clock in the morning. Where conventionally we would have a multitude of line breaks, especially in an environment like the Erdene 3D, where we have villages and major highways and lots of infrastructure, cement plants, etc. We would know the night before we're going to send a troubleshooter to that area to start remediating any cable issue. Or in the morning, as soon as the vibes are warmed up, their hydraulics are pressured up, we're in production. With the status of the units that we're pulling in from the line viewers, what we're looking at is the health of the GPS, the health of the battery, the health of the GSR, and the health of the geophone deployment as far as spread noise, tilt errors, impedance errors on the geophone. We have that data real time in the line viewer. In regards to OYO's front end on their line viewer software, there's a very user-friendly interface for the line viewer that OYO spent a lot of time on developing to minimize the complexity of it. It's simple. If it's green, it's good. If it's red, it's bad. So it was a very easy transition for the laborers to identify a light, to see how that light blinks, and if it blinks the proper code, they carry on to the next station.
OYO's solution to spread QC was their line viewer technology. Yes, you cannot bring back data real time, but we do have the ability, if you put the right procedures and protocols in place, to QC your spread on a continual basis and ensure that your boxes are working, your geophones are working.
Right now we are checking spread with 3 guys with line viewer. It's very easy to use. You can check everything about this receiver position inside 1 second.
So if you've maintained your equipment, if you've coupled your geophones properly, and you have a method such as the line viewing technology in order to continually QC your spread, you're going to get good data at the end of the day.
The GSR Autonomous Nodal Recording System is scalable to very high channel counts without the typical exponential increase in equipment and logistical complexity, personnel, or HSE considerations imposed by cable-dependent systems. The system's flexibility allows it to be seamlessly integrated into or used to supplement existing acquisition system equipment.
In regards to the GSR, the channel count capability is virtually unlimited. Theoretically, it's up to the contractor on how much equipment they purchase from the manufacturer. We could go out and lay a 50,000 channel patch on the ground, where a cable system, there was a test done with up to 90,000 channels, and it was very troubleshooting intensive, very time intensive, and non-cost effective. Whereas it's seamless. We can integrate this system onto a cable crew and scale as many GSRs as we'd like on that cable crew with this, to have utilize the cable crew in the more of the rural areas and just completely flood an urban area with GSRs and pull a better data set in that way. So we have the capability going forward, if we do have a client that's interested in the GSR but not willing to dive into it, we can rent a cable system and then high grade our GSR into it to show them the benefits of the GSR. I see with our future with VGS, stepping into the autonomous recording system will allow us to tailor projects to any specification of any client.
The flexibility of the GSR system design means that the survey isn't constrained by the economic or logistical limits imposed by cable-dependent acquisition systems. If necessary, a survey using autonomous nodal technology like the GSR can be designed with ample oversampling, which is an effective way to ensure comprehensive, high-resolution data recording. The field crew size for a survey project using GSR technology is usually only about a quarter or a third the size of a typical cable-dependent system crew. Smaller, more efficient crew sizes reduce operating cost, lower environmental impacts, and contain fewer HSE risks.
We have currently 23 full-time field staff employees. On a cable survey, our typical crew count would be, on a project this size of 200 square kilometers, we would have a crew in the words of 70 to 80 personnel on the crew. So we have had about a 30% reduction, more or less, with personnel for this, with an increase of productivity close to 50%. So the mathematics work out very good on that.
Because of its uncomplicated design, field personnel can learn to deploy the GSR system in only minutes. The GSR system's connections are all straightforward and virtually foolproof, and simply don't require specialized knowledge to deploy. The GSR system has minimal impact on landowner operations and the environment. Because each GSR station is robustly engineered and occupies a very small footprint in the field, common maintenance issues like human interference and damage by local wildlife are kept to a minimum.
Well, the topography of the survey is very gentle overall. Farmland, rolling hills, but we do have some challenges. We have 11 villages on the program, some of them of a relatively good size, and with the wireless technology, we've been able to deploy our receiver stations throughout the villages on this prospect without having even one station off pre-plot, something that would be virtually impossible to do with a cable crew.
With the GSRs, obstacles are not an obstacle. If you have rivers, if you have lakes, if you have no permit spots, you can still have one GSR out on one side and one on the other, and you can still get the data. You don't have to worry about rerouting any cables.
Everything goes away with a wireless crew. Everything becomes invisible. There are no more major highways. There are no more major creeks. There are no more villages. There are no longer any challenges that prohibit you from getting high production at the end of the day. It's always what I envisioned.
For field deployment, Oyo Geospace provides a purpose-built Mobile System Manager MSM trailer that serves as the nerve center for the management of the project in the field. The MSM centralizes all the systems needed to support seamless GSR system field deployment and data management.
In regards to our recording truck or command center in the field, we have a 40-foot shipping container. The vision was to make a trailer that's capable of being packed up, locked up, and thrown on a cargo vessel, and at the same time making it comfortable for the employees that work in it throughout the day. So the structure of the trailer is the rear entry of the trailer with the swing doors is meant for the battery charging and the data harvesting. There's a separate room in that area with a fire door that blocks off a secondary office for the transcriber or the data reaper. From that door, there's another mud room and another fire door to the operator console where the observer is actually taking the shots in it. So upon design, we made it flow through very well. The initial product's put in the rear of the trailer, it's processed in the center, and then the data coming from the FMC, from the observer, can just be brought into the transcriber room in the middle of the trailer. Currently, when we mobilize the crew, our biggest mobilization portion is our Toyota Hilux support vehicles. In regards to the OYO system, the command center, the physical geophones, GSRs, and batteries, we have two 40-foot containers that will house all that with a trailer that was brought from overseas into Turkey. We hire a transportation company, they're hooked up, and those vehicles are gone. They're towed to the job site prior to us going, and then we have a convoy of our support vehicles down the road.
Portability was a very important piece of how we designed our crew. Knowing that we were going to support transatlantic in more than one country, we just didn't want to have the ability to be able to move very rapidly from prospect to prospect, but be able to rapidly move from country to country. We can pack up our 3,000 channel acquisition system in one 40-foot container trailer, put it on a boat, and have it in Morocco within 2 weeks. So portability, what it's all about, and I'm very excited. I think we have the ability with this crew to move it anywhere in the region for such a low cost that I don't believe anybody can compete with us when it comes to mobilization.
Every MSM is configured to meet the customer's field needs while containing all of the ancillary systems necessary to support seamless GSR field deployment and data management. One of the key components to be successful in the seismic industry today is to run a safe operation. Most quality companies are highly concerned about HSE and the overall safety of their employees.
The HSE issues speak for themselves. I mean, we have less people in the field, so less opportunity to have people hurt. And I think there's also an advantage just for the fact of not having cables. Really, that's the heaviest component on the crew in regards to manpower is laying out and picking up the seismic cables. And you know, we have this lightweight system out there that we put this 2.5-pound box on the ground, we hook it up to a small battery with a set of very lightweight land geophones, and so overall there's very little strenuous activity taking place on a seismic crew in Turkey today.
In regards to the weight with the equipment, it's 1/10 the conventional weight of a cable system. We're talking 2 pounds, 1 kilogram more or less for a GSR and 3 kilograms for a battery. It's unheard of. That was the weight of a set of phones. So to deploy one station of GSR for the laborer, it's literally lifting 2 sets of geophones, conventional geophones, where there's less muscle strain on the individual. The fatigue levels are completely reduced and or eliminated with the equipment.
OYO Geospace's GSR nodal system substantially reduces the potential for HSE issues in the field in several critical aspects. 1. The smaller number of components reduces the size of the crew, the actual number of people in the field, and the likelihood of any kind of field incident. 2. The dramatic decrease in the weight of the equipment carried by each man also reduces the likelihood of injuries and strains.
What do oil companies want? They want high quality data, they want it acquired safely, and they want it as cheap as they can possibly get it. And those are the drivers in the industry. They've always been the drivers in the industry. The guy who wins in the seismic game is the guy who acquires his data for less cost and still puts some money in his jeans at the end of the day. Viking Geophysical was formed to support the transatlantic companies and provide internal seismic resources. My goal is to acquire high quality data cost effectively for our company, but at the same time to offer our services to the other oil and gas companies in the region, to put together a crew that was nimble and lightweight, that would operate for less costs. By running with wireless technology, we're able to operate with fewer people, smaller vehicles, fewer vehicles, we're consuming less fuel, and our overall operating cost is significantly reduced through this technology. I believe we've headed down the right path, and I believe we put ourselves in a position that very few of our competitors are going to equal. And I'm looking forward to the next 2 or 3 years of proving out this technology and setting production records, at least in this part of the world, that are yet to be seen. So we're open to business for not just transatlantic, but all of the oil and gas companies that are exploring in Turkey, Romania, Morocco, and beyond.
A leader in the seismic instrument and equipment business since 1980, Oyo Geospace designs, manufactures, and deploys seismic instrumentation, reservoir monitoring, cable umbilical, and thermal imaging solutions to provide customers with the best products and services available in the industry. A new day is dawning in the seismic industry as oil and gas companies demand higher channel count, seismic surveys, and continuous recording capabilities. Oyo Geospace's latest seismic solution, the GSR, is a game-changing system.